Welcome back and thank you for joining me. Today we're going to move on to our next section, 9.5, our last section of the chapter. We're going to wrap up by discussing geometric series. So we spent the last two sections, two lessons, talking about arithmetic series when you're adding and subtracting over and over and over again. Well, today we're transitioning to geometric series, so when you're multiplying over and over and over again. And once again, a series, we're talking about adding up all the terms in that sequence, all right? So there's a new formula for us to know. On the bright side, again, you're not going to have this memorized for me on your test. You are going to get that sheet to use. But I want you to note the pieces that we need. So in order to use this summation formula, we need to know A1, we need to know the rate that it's changing at, and the number of terms. All right? So keep in mind, those are the 3 pieces of information that we need in order to calculate a sum using that formula. So just like with arithmetic ones, I've created a couple examples just to help you get used to the formula. So here I've given you everything you're going to need. You just have to be able to plug it into that formula. So let's take a look. Here, it looks like I'm multiplying by 2 to go from term to term. So that's telling me my A1 is 3, my rate is 2, that's what I'm multiplying by, and the number of terms I can physically see. I have 1, 2, 3, 4, 5, 6 terms in that series. So these first couple, again, I know are going to be very easy, but I want them to be because I want you to be able to see what's happening. So let's plug that into the formula. So my summation formula says A1, which is 3, 1 minus the rate, which is 2, to the n power, all over 1 minus that rate of 2. All right, so notice how carefully I've put all of this stuff in. All right, the extra parentheses I added around the 2 right there. That'll come in handy whenever you're dealing with a negative number. So get into the habit of doing it now. Okay, so the biggest thing here is most kids can put it in the formula. Okay, this is not the issue. The issue is now getting this to be an answer. All right. So let me show you how to appropriately plug this into the calculator so you can always get the answer right. So in the calculator, I'm going to type in that whole numerator. 3 times 1 minus the rate to the nth power end parenthesis. All right. If you type it in exactly as I have here, using those parentheses every single time, that will give you the numerator, okay? Negative 189. All right, now I have to divide by that denominator, and the denominator was 1 minus 2. And that's what changes it to the positive value that I know that I should be getting. All right, so in this case, I get a positive 189. So, and then maybe I should put those there for you too. But that sum is going to be 189. So, and again, it's very, very important that you use those parentheses exactly how I typed it in. Calculate the top, hit enter, then calculate the bottom. So let's try this again. Well, here, as I'm going from term to term, to me, it seems fairly simple, but I know you guys, again, you're just getting used to this. So if you can't see that you're multiplying by negative 1/2, again, all you have to do is take the first term or the second term divided by the first term, and that'll also get you that negative 0.5, okay? So if you can see it right away, fantastic. But again, if you can't see what you're multiplying by, Take the second term, divide it by the first term. That'll give you whatever you're supposed to be multiplying by. The first term is 20. And how many terms do we see this time? I see 1, 2, 3, 4, 5 terms this time. So let's get this plugged into the formula. So Sn is the first term, 1 minus the rate to the nth power all over 1 minus the rate. Now you can type this whole thing into the calculator. You just have to be very careful. You have to be very meticulous with how you write this in. So 20 times 1 minus, now the rate was negative 0.5 to the fifth, to the fifth power. So again, calculate the top, and you absolutely do need those parentheses, okay? Every parenthesis you see me use up here, you need to be using in the calculator. Hit enter. And now I'm going to divide by the bottom. And the bottom had 1 minus that negative 0.5. And that gives me 13.75 for my sum. So not too difficult, you just have to know exactly where to plug these things in. All right, now what about this? What if I show you ones that look like this, where I give you the beginning of the sequence, and then I just tell you how many terms you go out to? Well, this is actually all the information that you need. Let me explain to you what I mean. So here, I think you guys could pretty quickly gather that you're multiplying by 5. So my rate is multiplying by 5. My first term is 6. And if they just give me the n like that, it doesn't matter that I don't know what the last term is. Remember, in this type of sequence, in geometric series, I don't actually need to know the last term of the series when I go to do this. So let's plug it all in. So the first term, 1 minus the rate to the nth power all over 1 minus the rate. So show me the formula, and now plug that very carefully into your calculator. So A1, 1 minus the rate to the nth power. As soon as you have the numerator, hit enter, and now let's divide it by 1 minus the rate. All right, and that gives you 2929686. So this time we got a really big answer, right? So I want to put in my commas. Yeah, we're talking almost 3 million for this one. All right, and our last one for this page. So this time the rate isn't that obvious, is it? It's not that easy to see 8 times what will get me negative 12. So remember, if you ever don't know, just take the second term, divide it by the first term. So negative 12 divided by 8 is giving me negative 1.5. Okay, so don't forget that little trick. If you can't see the rate, just second term divided by the first term, boom, you've got it. A1 is 8, and n, they're telling us we're going up to 12. All right, let's plug it all into the formula. My first term, 1 minus my rate to the nth power all over 1 minus my rate. So let's very carefully plug this into the calculator now. 8 times 1 minus, oh, the rate to the 12th, oh, I'm sorry, to the 12th power. So again, just type in everything in the numerator, hit enter. Now, let's divide it by that 1 minus the rate. All right, and here we have our answer, negative 411. And then here, let's just approximate this, okay? This decimal is going to be really long, really big. And with such a big number, that would make a really nasty fraction. So let's just round this up to negative 411.99. Now, if we did want the fraction, we could easily get that. Math bracket, and you could write that down, which I love fractions. If you wanted to give me that, fantastic. But since it's such a nasty fraction, in this case, I am okay if you just want to round the decimal for me. All right. So remember, if you're missing a piece of information that you need, use the explicit formula to help you find it. So here, I can see that I'm multiplying by 2, so my rate is 2, my first term is 3, but I don't know the number of terms, okay? That's the last piece of information I need, and I don't have it. So remember, use the explicit formula if there's anything that you don't know. So my last term is 384, so that's going to be my AN. Then I know my first term is 3, and I know my rate is 2. I'm looking for N. All right, well, let's divide that 3 out right away. So I get 128 equals 2 to the n minus 1. All right, so the 128 there, 128 is some power of 2. All right, so I'm going to rewrite this using that as some power of 2. Now, we don't know what power that is, so you can either use your powers chart or let your calculator help you. Is it 2 to the 6? No. Is it 2 to the 7? Oh, there we go. I found it already. So if you don't have your powers chart handy, you can just run through the calculator and find out what power of 2 is that number. In this instance, it's 2 to the 7. So I'm going to rewrite it like that. 2 to the 7 equals 2 to the n minus 1. So I'm hoping you can see that the only way that these two things could be equivalent is if those exponents are the same, okay? Because you have the same base, so that means the exponents also have to be the same. We'll get more into that come when we go back to chapter 7, but for now, this is all you need to know. If you have common bases, the exponents have to be the same, and then I get my n is 8. Now that I have that my n is 8, now I have everything I need to actually do the summation. So the first term, 1 minus the rate, which is 2 to the 8th power over 1 minus the rate. All right, so let's plug this into the calculator and see what we get. 3 times 1 minus that rate of 2 to the nth power, which was 8. Once you have the numerator typed in, hit enter, and now divide it by 1 minus the rate. And that's what gets you the positive answer of 765. Now, the last thing that we need to talk about in terms of different ways you can see these is in summation form. Okay, so summation form, you're still looking for the same three things. Okay, the first term, the rate, and the number of terms. Now, A1 is, of course, when you just plug in 1 for n. So 4 times 1/2 gives me 2. The rate is actually whatever is in there, whatever is being taken to the exponent, that is your rate. So in this case, our rate is just going to be 1/2. And the number of terms, if we're going from 1 up to 5, there are 5 terms that we're looking at. So again, it's really easy to get that information. You just have to remember how to pick it out of that summation formula. Okay? So let's plug everything in. 2 times 1 minus 0.5 to the 5th power, all over 1 minus 0.5. Once you write it out like this, now just put it in the calculator for me. Oh, and I need to remember, okay. 2 times 1 minus that 0.5 to the 5th power, oh, extra parenthesis there, hit enter, divided by 1 minus 0.5. Now I get 3.875. All right, let's try this next one. Again, we need to piece out all of the proper information. Okay, A1. So A1 is when I plug in that first term. I plug in that 0. Okay, so 5 times 1/2 to the negative 1. So 5 times negative 2 to the negative 1 gives me a negative 2.5. So my first term is negative 2.5. My rate is whatever is being taken to that exponent. So my rate is negative 2. Now, my number of terms. So this is where I'm going to caution you. So we're used to thinking of just whatever that top number is, but that's when it goes from 1 to the top number. Here we're going from 0 up to that number. So that means we have an additional term. We're starting at 0 instead of 1. So we actually have an added term in here. So be careful when the summation isn't 1 to some number, because then you may have to be careful about you have some extra or less terms than what you're expecting. Once you've done that, now let's plug everything in. Our first term, 1 minus our rate to the n power over 1 divided by our rate. All right, so negative 2.5 times 1 minus that negative 2 to the 10th power, and now divided by 1 minus that negative 2. And we get 852.5. So all it is being very careful with how you plug it into the calculator. That's really the big idea of this section. Just be very careful with plugging it into the calculator. All right, so let's do these word problems and then we'll call it good for the day. A famous story involves a soldier who rescues his king in battle. The king grants him any prize within reason from the riches of the kingdom. The soldier asks for a chessboard with a single kernel of wheat on the first square, two kernels of wheat on the second square, then four, then eight, and so on for all 64 squares of the chessboard. The king decides that the request is reasonable. So, according to this story, how many total kernels of wheat did the soldier request? Well, how many total kernels? That's going to be the summation of all of those pieces. So let's think. On the first piece, he asked for one kernel of wheat. Okay. And then what did he ask for? Well, he asked for two on the next one, four on the next one, eight on the next one. So what was he doing? Well, he was doubling it. So he had a rate of 2 that he was doubling this by. And then how many times is he doing this? Well, there's 64 pieces on a chessboard. All right, so let's plug this into our summation formula. So we have A1 times 1 minus that rate to the 64th power all over 1 minus that rate. All right, so let's take a look. 1 times 1 minus that rate to the 64th power. And now we're going to divide that by 1 minus that rate. Now you may be wondering what this is. Okay, our calculator, we got a number so big, is giving us this mess. Well, remember, this is scientific notation. Okay, so this is really signifying about 1.84 times 10 to the 19th power. So picture moving that decimal place over to the right 19 times. That's how many pieces of corn he was asking for. So 1.84 times 10 to the 19th power kernels. An insane amount. That's a huge amount of corn. Okay? So, let's put this number in context, because when we get numbers that big, we don't even know how to think about them. So let's put that number in context. A bushel of wheat contains about 1 million kernels. The total U.S. output of wheat in recent years was just over 2.1 billion bushels. How many years of production at that level would it take the United States to produce enough wheat to satisfy the soldier's reasonable request? Okay, so bushel of wheat contains about 1 million kernels. So let's see how many bushels this equates to. So I'm going to take that, and how many bushels will it be? Well, let's divide it by that million. 2, 3, 1, 2, 3. All right, so I'm dividing by a million. So it's still 1.84 times 10 to the 13. Oh, sorry. So that's how many bushels of wheat we're talking about. Well, if the U.S. can produce 2.1 billion bushels, well, let's divide by that to see how many years it's going to take to make that much. So we need to now divide this by the 2.1 billion. All right, so without these decimals, let's make sure. So here, that's not quite enough yet. We need 2 more zeros, because here now, there, is 2.1 billion. All right? So just be careful with how many zeros you're putting in there. So now it would take 8,784 years to make that much corn. Sorry, 84. So the US alone, it would take that long just to make that request. So it seemed reasonable when you take into account the geometric sequence isn't actually that reasonable anymore. All right, so thank you so much for joining me. I know this lesson got a little bit longer than what I was expecting, but thank you for sticking through with it. So make sure you write your summary and then come back ready to do your practice work.